Hello, everybody. Uh-oh. It's doing that thing again. Let me fix that. And how about that? A little bit? How about now? Still a little bit. Was. Problems. Oh, I'm not on the mic. How about now? Hey, okay. Sorry about that. There's something really weird with our DSP that's when the mic's completely off, it's not off, it just echoes. Something's not right. Anyway, I'm Andrew Rogers. I help run Chaw Devs. We're happy to have everybody here for lunch. You see our sponsor logos up here. Really happy to have those sponsors. Happy to have any new sponsors who are interested as well. Looking at squid as they continue to grow. And so anyway, we're really excited also to have Micah here talking about Prometheus, which is a subject that I'm personally really interested in and monitoring in general, but Prometheus is a really cool project. So I will not delay any longer or make this any more awkward. Brett is better at that than I am, but I could just keep talking like this kind of low. Anyway, Micah, everybody.
Good? Okay, cool. So I'm Micah Hausler, I work at Squid, and wanted to talk about Prometheus and time series monitoring because I've just found it really interesting as I've started to read about it, learn more about it, use Prometheus itself. So I hope you all find it interesting and are able to get some use out of it. I want to start out with some background and talk just about monitoring systems in general. This is not specific to Prometheus necessarily, but this is just what do we look for when we're monitoring, particularly a web application, but this applies to other things as well. I'm going to talk about 4 golden signals. These come from the Google SRE book, which I highly, highly, highly recommend reading, and I'll talk about that later. But so the signals to look out for when you're running an application primarily are latency, traffic, errors, and saturation. If you're monitoring these 4 things, you're covering most of your bases. These are not the only 4 things to watch, obviously, but these cover most of the failure cases and will actually tell you when things are going wrong, or hopefully starting to go wrong before they really go wrong. Talking about latency first, let's define this. How long does a request take? Now this could be a web request, but this could also be a database request. This could be a transaction request. It's important to distinguish when talking about latency, successful and failed requests, because if you monitor, if you just have a number that's your say your average latency across all your requests, that could be really skewed by your errors. If you break out your latency by successful and failed requests, you're going to get a much better idea of how your system is actually performing. Because failed requests could be really fast, right? Like, can't talk to the database, give up, done. Or they could be really slow. Database connection is taking a really long time. Database connection takes, say, 60 seconds to time out. Or say you have an RPC that's taking 60 seconds to time out. So that can cause your latency to vary really widely. That's one of the reasons why it's important to differentiate those. Traffic. How much demand is being placed on your system? For web, this could be number of HTTP requests per second. This could be for say an audio or video application. It could be network I/O. That could be your limiting factor. For a key value store, it could be transactions per second, how much you can handle. And errors. So some errors are explicit. The system returns a 500 request. Something went wrong. Or these could be implicit. You might get, say, in HTTP context, a 200, but with the wrong content. And so you have to have different ways of looking for errors based on these implicit and explicit failures. With an explicit failure, it might be just how many 500s do I have? With an implicit, you might actually have to parse content. And then saturation, and that really just means how full is the system. Most systems, if you've ever run anything, you'll find out, most systems degrade before they're 100% utilized. So knowing what your target is, for what your normal operating target is, and then some additional weight you can carry. Say you're running a load balance set of 3 systems. Okay, that's for maybe failover, but what happens if all 3 systems are at 70% usage? Well, then if you lose one, you're going to have more than 100% usage on your other 2 systems. So you need to really know, what does 100% look like, what does 90% look like, what does 80% look like. So we'll kind of talk first about a pretty typical monitoring setup. A lot of monitoring services, like especially paid services, have a setup very similar to this. This is not necessarily bad. This is just a typical setup where you have your monitoring system and you have, say, your server, your application, and you have an agent, say maybe on that server, or a plugin in your application, maybe it's a library that you install, to send metric data to that monitoring system. There are a few drawbacks to this. This is not totally knocking on them, but there are a few drawbacks. Metric data can be in any format. It takes an additional processing for your host to run an additional agent. And then report failure is not a signal. So if your agent just stops working, that could be a bug in the agent. That could be a firewall rule that got changed. That could be all kinds of things. It could be that the system is overloaded and the killer killed it. You don't necessarily know. So that's one of the drawbacks to this. So let's talk about an alternative. Prometheus, which you're all here today to hear about, actually does the inverse. It goes out and scrapes its targets. So, and not only scrapes them, but it doesn't scrape an agent, but it scrapes just an HTTP endpoint on your service. So if that's a server, you might have a small process that exports these metrics to Prometheus. If you're running a web application, you just add an endpoint that Prometheus can fetch information from about your server, your service itself. So let's look at what does a single metric look like. So say we had a web server on port 80 and we had a slash metrics endpoint, and we wanted to know how many HTTP requests has this server served since it started up. So the format for Prometheus is just to give the metric and then a number. So this is good. This is giving us a data point, but obviously this is not the end, right? This is not all that insightful. Like, this does tell us about requests, but this doesn't tell us how many of those are errors or any other kind of information. What endpoints did that hit? So let's talk about this one data point though a little bit more first. So when we talk about time series data, we're really just talking about dimensions of data storage. So that previous HTTP requests parameter we saw, so this is what we're going to call this one time series arena for just HTTP requests. And we store it basically in 2 dimensions. We see the X on this specific graph as hosts that we scraped from. Say you have your service running on multiple hosts. And then Y being time, and time minus delta, time minus 2 deltas, and so on. So we now have a time series of this data point that we want to know about HTTP requests. So before we go a little farther into this format, I want to play out kind of the math of this. And about really about storage, because that becomes important when you're talking about storing information. So let's talk about a single metric. Generally in Prometheus, single metric takes about 24 bytes. So if we talk about 1 minute scrape intervals on your system, and say we want to have 12 hours of data, you could configure that to be more, for sure. But just as a case study, 12 hours of data, because that kind of gives us, okay, what is, are things rapidly changing toward in a negative way? That kind of gives us enough information. Well, let's do the math on that. 12 hours times 60 minutes in an hour times 24 bytes comes to about 16 kilobytes per data point that we're monitoring, right? For a single host. Say you have a machine that has around 7 gigs, or 17 gigs, excuse me. So that's, 2 to the 30th gives you a gigabyte. Multiply that by 17. Taking this math farther, we see, okay, when we divide our 16 kilobytes by that 17 gig number, we get just over 1 million time series data points or data arrays that we can store on a 17 gig system. Just to give you kind of a ballpark number of, okay, how much data can we store? So that's great, right? That's a lot of data. Except this graph that we saw earlier, this time series arena, where x is host and y is time, is only 2-dimensional. And like we said, we want a few more dimensions than that. This is where we get into like multiple dimensions, right? So what does a multi-dimensional metric look like? You can see here, this is if you were to scrape 5 different hosts. And you wanted multiple dimensions on that data point. So you wanted what variable am I measuring? What job is this running? What's the instance that I'm running this against? What is the service, and what zone am I in? Now we don't just have 2 dimensions, we have a lot more than that. We have 5. And so you can see the different values over on the right for each, that comes out to each instance. So thinking about this now, each query that we specify is a vector in this multi-dimensional array. Whether it's a host, and it's, say, if we're thinking just in 3 dimensions, that might be the z-axis. Whether it's a single host in time, that might be the y-axis. Or if it's a single point in time, that might be the x-axis. So let's talk about those data points for a second. There's 4 metric types that Prometheus uses. The first being a counter, and this is a number that only ever increases for that service. And that doesn't persist across restarts. This is probably the most useful type of information because between scrapes, you can actually visualize what is changing. The other type is a gauge. It's a dynamically changing number. So that might be something like % disk full. The advantage of a counter over a gauge is a gauge can vary all over the place, right? Like say you have a 30-second operation where your disk incurs a gigabyte of writes and then deletes the file, and then within 60 seconds. And so between your scrapes, you could be almost getting full disk without knowing it. So that's where a counter becomes really helpful. Other data, those are the 2 primary types that you'll use. But histograms are also a data type for Prometheus, as is summaries. Histograms are useful for things like AppDex scores. So what is the level of acceptable requests that are going through? And those are split up into buckets. Summaries are very similar, but slightly different. It's a sample observations, and you're calculating quantiles over a sliding time window. So just to give a quick example of a histogram, this is a Prometheus metric from a server. These are all zeros, but you can kind of see based just on the metric name itself, or the metric labels, the different buckets that we put things in. And those are configurable. And then with a summary, very similar, but we're actually specifying a quantile. Basically, the bottom line is if you use a summary, you control the error in the dimension of your quantile. And if you use a histogram, you can control the dimension of the observed value. So I don't want to get too deep into the weeds on that, but it just has to do with really where's the error, how wide is the standard deviation error margin that you're looking at. So with that, I kind of want to jump into a demo because this is all really cool, like mathy stuff, but like what does that actually come to? It's kind of abstract. So let me jump over. Play. So I have created a Docker Compose setup for running just Prometheus and a few other services, so you can kind of see what does Prometheus look like, how do you actually use it, and how does it actually scrape things. So I'm going to turn this on. I'll have to turn that on. Grafana was waiting for the database to come online. Okay, and we're up. So, the processes I'm running here are going to be Prometheus itself, the server. I'm using a process called cAdvisor. I think it's by Google for machine monitoring. It's really lightweight, and it reports metrics in Prometheus format, as well as having a web UI to see, what's my memory use like, what's my CPU usage like, that type of thing. What processes are running, what Docker containers are running. But if I look at metrics endpoint, this looks like what we saw, kind of what we saw before. Scroll down to something that's more interesting. Okay. Nope. Yeah. Okay. So you can see here we have network packets dropped total per interface. So that's not all that interesting, but we don't actually, as a human, want to look at this page very much. So let's hop on over to Grafana, or not Grafana, to Prometheus, excuse me. So Prometheus this is the UI. It's just, you can see it's bootstrap theme. Prometheus itself doesn't have like authentication and encryption for the web interface. It just says do that yourself. It's really just an internal monitoring tool. Put a proxy in front of it, do whatever you want, but keep things simple for Prometheus. So this is the main query and graph browser. I've pre-configured Prometheus. I can show you the configuration really quick. This is a YAML configuration file for Prometheus. In it, you configure what am I scraping. So remember, we're outbound scraping. And the two things I've configured are, one, for Prometheus to scrape itself. Job name is Prometheus. The target is hostname, and then port, so Prometheus. And then cAdvisor, which we saw over there, and to scrape the /metrics endpoint on that. Has a lot of other ways to configure what to scrape. These are hard-coded hosts, but it can do DNS serve lookups. It can look up. There's a lot built in. Like it can talk to console if you're using console as a service discovery. If you're using Marathon on Mesos, if you're using Kubernetes, it will automatically look at those APIs and figure out what systems you're running and start scraping those for metrics. It's really great. So let's jump back over to the graph. We can look at what metrics do we have available to us. This is just a list of all the things that we're scraping and the metrics that they're reporting to us. So let's go to something like, I don't know, what's something interesting? In your memory. going to take a second. Okay, we'll look at go routines. This is the number of, if we can refresh that. Is everything running? Where I ran this beforehand. Okay, so here's a graph view of the number of go routines that we have running as a metric reported by Prometheus. Here's you can see, I don't know if you can see that really quick, the labels on those two metrics that are reported under go routines. One is CAdvisor, because CAdvisor is a Go program, and Prometheus itself is written in Go. So we can see the label is Prometheus, instance Prometheus, job CAdvisor for CAdvisor. So we can do things like, okay, if I only wanted go routines running for the job equals Prometheus, I would just select that. That's the query. And this is a graph built up based on data points over time. If we, so that kind of gives you an idea of the query. And that, like I said, there's all kinds of other queries we can do. So let's see. Another query on memory. So there's memory on some other memory usage on other containers that CAdvisor is reporting about my Docker host. Those are the graphs. So besides just doing graphs in this query browser, there's all kinds of mathematical operations we can do. Say we wanted percent memory used. Well, okay, we have the number of bytes used by each container. If there was a limit, we could just do a divide and then the limit. Say it was 100 megs. You could put that in there and it would show you a percentage number. So I'll actually show that. Grafna is a tool that builds on Prometheus. It imports from a number of different data sources for like dashboard, monitoring dashboards. Graphite, InfluxDB, that type of thing. So let's select Prometheus, call it Prometheus default. That's the container name in my Docker host, so it'll automatically route 9090. Add. Okay, so that data source is working. We'll import an automatic dashboard from that. So let's go over to our dashboards really quick. This is that imported automatic dashboard. We'll change it to the last hour. I bet I know why that's off, because the time on my Docker machine is off. That's why this is off. Okay. So you can see this small graph here of Prometheus ingested samples. But one of the nice things about Grafna is we can import dashboards. So let's go ahead. I pre-created, ignore that. I created one already on Prometheus. Grafna. And so here's a quick dashboard of memory used per container that's running. We're running Postgres, CAdvisor. Postgres and Redis are run so that Grafna can run. So this just gives us, if I select this graph really quick, I can see the query I ran. I'm just looking at container memory used bytes, and the name is Prometheus. So I can actually copy that query over into Prometheus and drop it in. If I execute that, there's our graph in Prometheus. Here's our graph in Grafna. So let's get back out of this really quick. There's CPU seconds per container. And then for Prometheus, one of the things I did in my Docker Compose was I limited how much memory Prometheus could have. So we see Prometheus running here has up to about 40% of its memory. If we look at that query really quick, copy that out so we can actually see that over in Prometheus. We just did container memory used bytes. The name is Prometheus over the limit. Execute. There's our percentage graph. So these are all great, right? Like, it's cool to have dashboards, but you actually want to know, okay, when is something going wrong? So what Prometheus has is it has alerts. You can write these really simple, lightweight alerts that are that build on that query, and then do stuff based on that. So in this case, say I had a Jenkins job running, or a Jenkins server running, and I had a number of slaves. If I wanted to be alerted, okay, my queue is being backed up and all my slaves are working, I would construct a query like number of Jenkins workers in use over the total number of Jenkins workers, so we're at equals 1, so we're at 100% usage. And my Jenkins queue size for Jenkins master is above 4. Okay, I'm going to hit an alert off of that. That's not active. But if we look at Prometheus high CPU, we see I made this metric. Okay, container memory usage for Prometheus divided by the limit. So we now get as a percentage is greater than 30%, 0.3, for 3 minutes. Fire off an alert to the alert service. That's a separate process for Prometheus, and give it these labels. So the service, we give the label service name is Prometheus, severity is warning. And then we also have a second one, but this one is if it's for 15 minutes, we set the severity to critical. They have the same name, same service, but just different severity, and they have the same query. The nice thing that Prometheus does, or not just Prometheus, the alert manager does, is it will suppress lower level alerts. So if you have and you can group, and not just lower level, but you can group alerts. So if you have critical alerts firing, you don't want to have a bunch of small warning alerts hitting you at the same time. That's going to add to the noise. So it just send you, depending on how you configure it, the most relevant alert. And also it has a bunch of different notification channels that it can notify you on. It can send to FlowDoc, HipChat, Slack, as well as PagerDuty and Webhook. And you can configure a decision tree. So let's scroll down here really quick. This alert here, we have service Prometheus severity warning. If I just drop this in to see where would this go, I've pre-configured, I'll show you this config really quick. I've pre-configured this alert manager so that if I have a match on the service Jenkins, it goes to the Jenkins team Slack. If the severity on that match is critical, it goes to Jenkins PagerDuty. Everything else, so Prometheus, a registry, cAdvisor, console, whatever. Everything else goes to the SRE team Slack. If it's critical, it goes to SRE team PagerDuty. And then inhibition rules are for suppressing and grouping alerts. And then the receivers you define down here. So SRE team Slack goes to Slack and this channel, PagerDuty, here's the service key. Okay, so if we look at this routing, that's all in YAML, it's kind of abstract, but if we look at the routing tree and match this label set against it, we can see if we have, if we have a alert that's service Prometheus severity warning, it will, and then we match label set, it will bypass the default alert fallback. It won't even go down the Jenkins tree because that didn't match, and it will go to SRE team Slack. If we make that critical, it will bypass Slack and go straight to PagerDuty. Okay. So that's just kind of a little example of how the alert manager works. And you can turn on silences like, okay, I'm getting lots of alerts. I don't want to know about all the other alerts. But if I open Slack really quick for it, we'll see that I should have gotten an alert. Nope. That's not it. There we go. Here we go. So we've got an alert, 12:30. That was sent to Slack because I was in an alert state. If we go back to Prometheus, you can see that that was firing. So that kind of gives you a walkthrough of how do alerts work, how does querying work, and here's just the view on Prometheus for our targets that we've configured. We can look at the links there to jump over to those metric pages. But yeah, so that's kind of, I'm trying to think if there's anything else on the demo. Yeah, that's pretty much it. Back to my slides. Play. So the last thing I'll quickly mention is, so Prometheus itself just stores its data on disk. It doesn't have, it's not like a distributed system where you have etcd that does self-replicating or anything. There's not anything like that for Prometheus. What it does instead is have federation. So in the same way that Prometheus scrapes itself for data, there's a /federate endpoint, and Prometheus can scrape other Prometheus servers for all their data, for some subset of that data, rename or add labels like, oh, I'm going to add a label because this came from Prometheus 1 or Prometheus A, and I have Prometheus B, and they're replicating each other, but you don't want the data to be back and forth. That's Prometheus's approach to high availability, as well as if you want, just besides to replicating each other, is to have some sort of hierarchy. Like if you had a Prometheus, say in a larger context, a Prometheus server per rack, and then one per data center, and then so on and so forth. You can have some more aggregation. So with that, are there any questions? Yep. Yep. Yeah. Yeah, I'll give you the mic so you can, everyone can hear you.
Does Prometheus stop running it so that its database doesn't fill up?
Yeah, you can configure, one, you can configure the event horizon, so how far back to keep data, and you can and I don't know about, I haven't looked into, like you're saying, like how much aggregate data to record for older information, but I'm not sure about that.
There is a roll-up capability that works exactly like the alert rules.
Okay.
So you can define roll-ups to happen on write, and that's generally a good way to do it is on a new metric at high resolution, check to see if you should write a low resolution metric that's however you want to aggregate the high resolution, and then write it, and then just you drop off the back of the high resolution and your low resolution stays there. So you write both at the same time, but keep the low resolution longer.
And one more point I'll say about, I didn't want to say this earlier, about alerting is like, okay, it's great to be able to be paged, like you want to know when stuff's wrong, but at the same time, you don't want to be paged in like the middle of the night when there's like something that is, can be automated, like disk is 90% full. Well, trigger a webhook to run a script. You have to have some separate service that runs that script. But in that case, those are like known, they're known solutions for a lot of problems, and those common problems can be automated rather than having a human alerted for every individual data point or every individual page. Anybody else?
How do you set up the monitoring for different web applications? I mean, you hit an endpoint, but what hosts the endpoint?
Yep. Yeah, so that's a good question. What's typically done is you'll use some kind of client library. There's client libraries for most languages, and it's not hard to implement either. It's like you saw the format. It's label, like curly braces, or metric, curly braces, label, or just key value pairs, and then a number. So you can either implement that yourself or use a library, and on your web application, create an endpoint for Prometheus. And Prometheus, it doesn't have to be unauthenticated. Like you can have TLS client servers, you can have whatever you need to authenticate your service, and have Prometheus use that.
I think it's also worth noting if you want to play with Prometheus and you already have a push type monitoring infrastructure put in place, and you don't want to blow it all away and put in a pull type, there is a project called Push Gateway. So if you want to play with Prometheus as a new backend for an existing monitoring system, you just spin it up, and it can take things like collectd or diamond or any other type of kind of push metric and generate an endpoint. And you can do that per host, or you can do it as like a server sitting next to your main Prometheus server that takes everybody's push stuff and then serves it up as a scrapable page for your Prometheus server.
Yeah.
You can even do it on the same server if your workload is small enough. So it's a good way to like play with Prometheus if you've got a graphite environment or some other existing metrics environment.
Another point too, I meant to say this earlier, about like the math section of 17 gigs or whatever. I'm just talking about in memory there. Prometheus also writes to disk, so that's just hot data that's immediately can be immediately queried. Otherwise, it might have to go out to disk, and it might take longer.
It's pretty smart about that. I don't remember what all it does, but it does kind of.
Yep.
It tries to keep the most recent stuff in memory and flush everything else.
Yeah, and I just got a PagerDuty alert about Prometheus. So, yeah.
Any other questions?
Yeah, you mentioned integrating it with something like Console or etcd. Does it have support for that already, or would you need to, set something up?
Yeah, so it's really about the service discovery side of things. So if you're using SkyDNS on etcd, it would be able to query what are the serve records for some service, or for Console, what are the serve records for this service, and be able to figure out, okay, these are the hosts and ports that my service is running. Yeah. Anybody else? All right. Well, thanks, guys. Here's a few links. I'll put these slides up online and tweet these out. But Prometheus, just prometheus.io. There's a link to the Google SRE book, and I put the demo that I have here. If you want to play around with it, I put it on GitHub. Read the SRE book. It is awesome. You will learn things, and it will be great for you. And thanks, Squid's hiring. So talk to me if you're interested in working at Squid. Yeah.
All right, thanks, Micah. See you all next week. Oh, Stuart's got an announcement.
Okay, this is going to be the last time you get to see me come up here, but we are a week away from tomorrow from Scenic City Summit. If you haven't heard about it, it's a developer IT conference. It's going to be on the campus of UTC in the engineering, math, and computer science building. We've got a dozen great speakers. It's an all-day event. Lunch is provided. It's going to be a great opportunity. If you haven't gone to the website, please go to the website, Scenic City Summit. Registration is $65. I really hope to see all of you there next week. Thanks.